Okay, so in the last video, we talked about mean, median, and mode, and range, and semi-range, or something like that, mid-range. And I also started to talk about standard deviation, which if you just have the mean, you don't know anything, because you don't know like that all the tests were 75. It could be that 3 were 100%, and this is 75. So here, the standard deviation would be 0. Like, these are really, they're exact. Here, you know, these vary by 0, 0, 0, but then 100, 100, 100. So your standard deviation here might be quite high, which tells you there's a lot of variability in your numbers. So I'm going to go up here. These all have a mean of 4. So I'm going to take this second row, B. Mean is 4. And again, you could add those up and divide by 4, or you could steal from the rich, give to the poor. Either way. All right, so I'm going to give you the formula for standard deviation, and we're going to figure this out by hand, and it looks kind of scary, but it's not that scary. And this is for a sample, like if you take a sample of DMAC or a sample, like not the entire population, there's a different formula. Okay, the best way to do this is to make a chart. So you need to, order of op, you have to do parentheses first. So we're going to do the X, then the X bar, which is your mean. And then after we know those, we're going to subtract them. After we subtract them, we're going to square it. And then we'll deal with the rest later. So the chart only gets us this top number, okay? All right, so X is our data. This is our data, so I'm going to write it down. We have a 3, 4, 4, and a 5. Our mean is the same for all of these. The average is 4, 4, 4, 4. Okay, now some of these are above average, some are below. So we subtract in order. So 3 minus 4, a negative 1 means that's below average. 4 minus 4 is 0. 4 minus 4 is 0. 5 minus 4 is a positive 1. It is above average. The problem is these should add up to 0 because, right, when you steal from the rich and give to the poor, it should all average out. But the problem is it's hard to do math with 0. Okay, because, you know, multiply by 0, you get 0. 0 divided by a number 0, it's illegal to divide by 0. There's just not much we can do. So someone who's way smarter than me figured out, well, let's square it so it's not negative anymore. So what we're going to do is we're going to take these numbers and we're going to square all of them and bring those answers over to the next column. Now, if you're using a calculator and you are squaring a negative, you have to put in parentheses because you want a negative 1 squared. If you don't put the parentheses, you'll get the wrong answer. It'll give you a negative 1, not a positive 1. So a negative 1 times a negative 1 is a positive 1. If you type in negative 1 and then raise the second power, you're going to get a negative 1 because it's going to square the 1 and make it negative. You want the negative squared too, so make sure you put in parentheses. Just know that this entire column, these numbers should all be positive or 0. They can't be negative. So even if you type in your calculator wrong and you somehow get, you know, a negative number, you should be like, oh no, I screwed up. Okay, so negative 1 times negative 1 is positive 1. 0 squared is 0. 0 squared 0. And this is a positive 1. Okay, and we are going to add that last column. So that is a 2. Okay, how does this formula work? This guy says take X minus the mean and square it. Okay, we did that. This guy is a summation. It's a Greek sign that says summation. Add it all up. We did that. We got 2. All right, so we're going to put all of that on top, 2. N minus 1, N is your sample size. So we have 1, 2, 3, 4 numbers in our sample. 4 minus 1 is 3. All right, now what does this say? It says take the square root of 2/3. Okay, so I am going to take, on my calculator, I hit the second square root first. So I'm going to hit second square root, which is right there. And I'm going to do 2 divided by 3. Enter. And so my standard deviation is about 0.82, I would say. Depends on how many place values they want. So you might, you know, they might want you to round to 4 or 3. You just have to do whatever my math lab says. All right, so what that tells you is this is kind of how they vary. So when I see the average of 4 and a standard deviation of 0.8, I'm like, you know, they vary a little bit, but they don't vary a lot. If we did one of these problems, we would get a lot more variability, okay? All right, let's do maybe another example here. Say I give you, say you have, I don't know, 78% on a test, and then maybe someone else has an 88% ARNA test, and maybe someone else has a 65% ARNA test. Okay, we want to find the standard deviation. All right, so we're going to average these first. So 78 plus 88 plus 65 is 231 divided by 3. That gives me 77. Okay. All right, so we're going to make the chart. So the formula is standard deviation is a square root summation x minus x mean squared divided by n minus 1. Really, it's the square root of the sum of the last column divided by the sample size minus 1. Okay. All right, so let's make our chart. We have x, we have the mean. That's this stuff. Next, we're going to subtract them in order. Last thing we're going to do is square that answer. All right, so what do I have? I like to put these in order. So 65, 78, and what, 88? Okay, so we're focusing right here. The mean is 77 for all these. If you get a decimal, we usually round to the tenths, but again, follow my method. All right, so now I'm going to subtract. In order, 65 is below average, so I should get a negative 12. So that is 12% lower than the average score. 78 minus 77 is a positive 1. 88 minus 77 is a positive 11. And note, these should add up to 0 because if I steal from my good grades to kind of compensate for my bad grades, they should all 0 out. And so that's not helpful with math. So now what we're going to do is we're going to take all of these and we are going to square them, square them, square them so that they're positive, okay? So again, on a calculator, if you want, you could just leave the negative off, like, because you know a negative squared anyway, so you could just, you know, not even put the negative in. Do not, if you get positive or 0, you're good. If you get a negative number over here, not good. This is 1, and then 11 squared is 121. Okay, all positives or zeros, no negatives. All right, so then what? I add up the last column. It says sum of the last column. Okay, so I'm going to add my 144 plus my 1 plus what? 121? And I'm going to get 266. Okay, right there. All right, what does the formula say? Sum of the last column, 266. Sample size, well, there were only 3 things in my sample, minus 1. So I have 266. 3 minus 1 is 2. And if you want to divide that first, you can. Just don't round it. So if it's an ugly decimal, write all of it. Like, you know, if it's ugly, just write a bunch of it. All right. So I'm going to take the square root of that. So second, you could do second square root, second answer, if you want. Okay, and I get that. Or you could just hit second and get the square root sign and then type in the 133. Either way. So I get about 11.53 is my standard deviation, which tells you again, so when you know the average and you know the standard deviation, that's actually helpful. An average without a standard deviation is really useless for a human. But if I look, you see how these vary by 10, right? These vary by what, 23? You know, this varies by what, 13. So if you kind of average all those differences out, you know, that's kind of what your standard deviation is. Not quite, but it's pretty darn close. Okay. That's how you get a standard deviation. Now, what does it mean? All right. So it does kind of tell how they vary, but it's more important than that. So Chebyshev is a Russian guy that came up with the statistics for this. And this is the normal distribution. And you use calculus to come up with these areas under the curve, but you know what? You don't have to know calculus. So someone else did this for us and we're going to use it. All right, so I'm going to make a normal distribution, which is I'm not super good at, but I will do my best. I can show you one from the book later. I'm going to try again. Sorry, I did not like my drawing. Well, that's a little better. Not perfect, but better. All right. So Chebyshev came up with the 68, 95, 99.7 rule. Okay. What does this mean? All right. So your average goes in the middle. So here's my average. He figured out that 99.7% of everything that's normally distributed falls within 3 standard deviations plus or minus. So I'm going to cut this 1, 2, 3. And notice it gets smaller as we go. 1, 2, 3. So things get rarer as you go to the tails. Okay. So what does this 68 mean? This means that 68% of the population, or whatever you're studying, is going to fall within one standard deviation, +1 or -1. So if I take 68 divided by 2, I get 34%. So that means 34% is over here, 34% is over there. Okay. Then he figured out that 95%, and we consider this normal, within 2 standard deviations is normal, 95% fall ±2. But notice we've already used up 68. So if I take 95 minus 68, I get what? 27% left for these two. And if I divide it by 2, that means that each of them gets 13.5. So this is 13.5%, and this is 13.5%. Okay? All right, notice it's getting rarer. So within 1 standard deviation, 68%, within 2, 95. Within 3 is 99.7. All right, so we have 99.7. We've already accounted for 95, so there's 4.7 left. Divided by 2, this is 2.35%, very rare, 2.35. So anything beyond 2 standard deviations, so kind of like 2 standard deviation cutoff, we consider rare. Anything outside of that are not rare, and anything outside of that we would say is rare. And notice you're like, well, what about these? Well, the whole thing is 100%, right? Our data, we have 100% of our data. We know that what 99.7 looks like. So if we subtract, there's only 0.3% left for the tails. Divide by 2, this guy's 0.15%. So less than 1% are in those tails, 0.15%. And these go off to infinity. They can get rarer and rarer, but in a sense, the area is 100%. Okay, so what we just did, and I can show you a better picture from the book because, let's see if I don't think they marked them though. Here's a better drawing. They just didn't put the percents in, but they did 1 standard deviation, 2, 3, -1, -2, and then they did the 68, 95, and that. But they didn't divide it into 34, 34, 13.5, 13.5, 2.35, 2.35, and then 0.15. 0.15 for the tails. They might do that later, so let's see if I can see that. It does not look like they did it. All right, I guess they decided that wasn't important. I'm not so sure. Okay, so let's go back to what we did with those grades. All right, so what did we have over here? We had an average of 77. Okay, so what that means is 77, let me use this, 77 is your mean. That is the score there, okay? Our standard deviation was, what was it, 11 point something, wasn't it? Our standard deviation, I'm going to round this to 11.5 to make life easier. So what we're going to do is we're going to go to 77. That's our mean. And we're going to add 11.5. So that means the next cutoff is what, 88.5? I'm going to add 11.5 again. And that's 100. And I'm going to add 11.5 again and get 0.5. All right. Then I'm going to take 77 minus 11.5. That might be 65.5. Minus 11.5 again and get 54. And minus 11.5 again and get 42.5. Now, if these are really percents, then this teacher must have given a lot of extra credit, right? Okay, so instead of maybe with this scenario doing percent, we could change these to points, like these were just points on a test. The other thing is I could say that these were degrees, like temperature outside, something like that, okay? So, all right, so what does that mean? So pretend those were degrees, okay, like temperature outside. Then the probability of the temperature being between 65.5 and 88.5 is 68%. The probability of the temperature being 54 to 100 degrees was a 95% probability. The probability of the temperature being 42.5 all the way up to 11.5 is 99.7%. Okay, what is the probability that the temperature is higher than 100, then what I do is just add those two together, 2.5% probability, okay, which is considered rare. What's the probability that the temperature is between 55